In the last part of or section, we looked at finding the sum of geometric series. But those were finite geometric series, where they only had a certain number of terms. If the geometric series goes on forever and ever, it's considered an infinite geometric series. Some infinite geometric series do have sums. Other infinite geometric series do not have sums. Consider this one over here. 1/3 plus 1 is 4/3, plus 3 would be 4 1/3, plus 9 would be 13 1/3. Then you'd be adding the next number, which would be 27. So in this one here, you keep adding bigger and bigger and bigger numbers. So it would not approach one particular number. The one on the left over here, you'd have 12 for the first two. Then you would have 14, then you would have 15, then you'd have 15 and a half, and then you'd add 1/4 into that, and you'd have 15 and 3/4, and then you'd add an eighth under that, and you'd have 15 and 7/8. So yes, your sum's getting bigger, but you're adding smaller and smaller numbers, so it would end up having a sum. So if your ratio is between 1 and -1, it has a sum. To be able to find that sum, you take your first term over 1 minus your ratio. If your ratio is not between 1 and -1, it doesn't end up having a sum. So consider this problem here. We need to first of all figure out our ratio. Remember, to find your ratio, you take the second term over the first term. So put -3/2 in parentheses divided by 3. See if that's the same thing as what you get when you take the third term of 3/4 over -3/2. So then you put negative or 3/4 in parentheses, divide, put -3/2 in parentheses, and you want to see what your ratio is. If it's the same, it's geometric. When we do that, we get -1/2. Now, if your ratio is between 1 and -1, of which -1/2 is, you have a sum. Then we can use our formula. So we'll go our first term over 1 minus your ratio. So this is really 3 on top over 1 1/2 on the bottom. We divide and we get 2. Looking at this one here, we need to find your ratio. Most of you will see that you're just multiplying by 2 each time. So your ratio is 2. So it's not between 1 and -1, so we would say it has no sum. This one over here, most of you are able to see that you're multiplying by 1/2 each time. 1/2 is between 1 and -1, so it does have a sum. Take your first term over 1 minus the ratio, so you get 1 over 1/2, which is 2. This is also an infinite geometric, and we can see that it's infinite because we have your infinity sign on the top. We could write this infinite geometric series out for the first several terms. Take 1, plug it in, you get 1/2 to the 0, so you get 1 times 5. Then we could plug in the next number, which is 2. You get 1/2 to the first times 5, so you get 5/2. And then you plug in 2, and so on, and you get your first several terms. And you can see that this does go on forever, and you can see that you're multiplying by 1/2 each time. But you can also see that from looking at this over here. Because what we have over there on the left is in the form of our geometric sequence, where the 5 is in the location of a sub 1, the 1/2 is in the location of the r. So you can see that it fits that form, so it's geometric, and it's infinite, with r being 1/2. So therefore, we should be able to go ahead and find the sum of your infinite geometric, taking our first term over 1 minus your ratio, and we get 10. Now this formula you can actually work out even if r is not between 1 and -1. However, the answer you get will not make sense in the context of the question. So let's consider the 0.25 repeating. decimal. And let's write that as a fraction. There's a couple ways you can do it. So 0.25 repeating is really 0.25 plus a 0.0025 plus a 0.000025 and so on. What we have written out here is an infinite geometric series. Your ratio, you take the second term over the first term, and you would get 100th. Or you could take the third term over your second term, and you would also get 100th, which is between 0 and, 1 and negative 1. So to find our sum, we can take our first term, which is 0.25, over 1 minus your ratio. Then we could type that in, or you could realize that you get 0.99 on the bottom. 0.25 over 0.99 is 25 over 99. That's one way to do it. A second way to do it, and by the way, up here in blue, that's using our infinite geometric series. A second way you could do it is you could say, well, I'm going to let n be my repeating decimal. Then you'll notice you have two decimal points being repeated. So let's multiply both sides of this by 100, which has two zeros, and it moves your decimal point over two spots. So n times 100 is this. Multiplying this by 100 moves your decimal point over two spots, so it's going to be 25. And then you're going to still have that 2.25, 25, 25, and so on. Now, if we take the second line away from the top line, so 100n minus 1n is 99n. Over here, when we take the bottom line away from the top line, the 0.25 repeating minus the 0.25 repeating drops out, so you're left with the 25 minus the 0 on the front. So when you divide, you still get 25 over 99. Now in this case, our fraction of 25 over 99 did not simplify. Sometimes when you do this, it will simplify. By the way, what does 0.9 repeating equal? Well, 0.9 repeating would be the same as 0.3 repeating plus 0.3 repeating plus 0.3 repeating. You should remember from arithmetic that 0.3 repeating is a third. So you get 1/3 plus 1/3 plus 1/3. And you guys know how to add fractions. You'd add the tops when the bottoms are the same. You get 3/3, so you get 1. So 0.9 repeating is 1. A second way you could think of 0.9 repeating is an infinite geometric series. It's 0.9 plus 0.09 plus 0.009 plus 0.0009 and so on. Well, it's an infinite geometric series. You could take your first term over 1 minus your ratio, which is 1/10, and then you get 0.9 over 0.9, which is 1. Or you could do it this bottom way with n being equal to your repeating decimal. So you go n equals your repeating decimal. One number is being repeated, so I'm going to multiply both sides by 10. I take my n times 10, I get 10n. Take and multiply this by 10, it's going to move my decimal point over one spot. So then I subtract the bottom from the top, so I get 10n minus n is 9n. And then over here, the repeating 9's drop, and I get 9 minus 0, which is 9. Divide both sides by 9, and they get 1. So yes, 0.9 repeating is 1.